Okay, I know there are going to be quite a few absences today, and I know that you need this for future reference anyway in case I'm out soon. So I wanted to leave you a video notes. I'm actually going to show you how to convert between decimal and binary, and then I'll show you how to convert back on Monday. And that's what our whole next unit is how to convert. So the numbers you and I deal with every day are base 10. Like if you hear 33 or 40 or 63 or 47, those are all base 10 numbers. You and I tend to only deal in base 10. Again, why did you take discrete? But in discrete, we have to know how to convert between different number bases, especially our favorite, which is binary. Binary meaning 2. I mean, that's kind of obvious, but maybe you need me to specify. And that's what your computer runs off of. It speaks binary. The best example of binary that I can come up with is binary is used in the algorithm that Netflix uses to make recommendations to you as to what you should watch or not, which also involves matrices, but anyway, that's a whole nother discussion. And binary, like, that's how a computer talks, is through binary. And then, of course, colors and stuff, it uses other number bases, so we're going to have to learn other bases besides binary. Okay. If you do not like this video, you have another option. There are going to be 2 videos on the same 4 problems, work 2 different ways, so you pick which way you like. There's also something called the hand trick. And you can look that up if you want to. It's not really my favorite. It's not my cup of tea, but whatever floats your boat. Okay, so if I'm wanting to go from base 10 to base 2, I have to think about my powers of 2. So I'm going to make me a 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 5, 2 to the 4. I'm going to make me a couple dashes. And in case you've forgotten, 2 to the 0 is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 16, 32. You can always ask your calculator if you're confused. And so our answers in binary literally meaning 2, so we can have 2 options. You can either have a 1 or a 0. You can't have, if I see the number 7 on your paper, the number 3, the number anything besides a 1 or 0, you're wrong. Binary only uses 1s and 0s. Okay, so binary for us, 33 meaning, like, yes, I need 2 to the 5th because I need a 32. 32 plus 1 is 33, so I need one of these. Again, 32 plus 1, 33. That's how I'm getting the 33. I don't need any of these. So literally my answer is 1, 4 zeros, and a 1. Maybe I can add enough zeros today. And that logic is going to help us with 3, 5, and 7. And then the other top part of the 8, Lord Jesus, the other top part of the 8, and the backside top 8 are yours. Okay, so if we're wanting to do 40, still using this same logic, so I'm thinking through my multiples of 2. I think for us, it's only going to go for today to 2 to the 5th, but of course we can go much higher than that. We're just getting an intro to what binary looks like. We could go 2 to the 20th. I mean, it could get a lot higher. But for today, it's only going to be 2 to the 5th. And still, if you want to write them underneath, you can. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 to the 2nd is 4. 2, 1. If you need to write them underneath to think it through, you can. So I'm trying to think through what combination of these is going to add up to 40. 32 plus 8 adds up to 40. So I don't need that one. I don't need any of these. So my answer is seriously 1, 0, 1, 0, 0, 0. Okay, same logic with 63. Make me a list. 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. 2 to the 0 is 1, 2, 4, 8, 16, 32. I'm needing my stuff to add up to 63. This one's a little harder. 32 and 16 add up to 48. I'm needing to get up to 63. 48 and 8. Well, I'm up to 56, but I'm not quite to 63 yet. Add 4 more. I'm at 60. And then, I'm going to need 61, 62, 63. I'm going to need all of them. So literally 63, that number in decimal, when you convert it to binary, ends up being all ones. 1, 2, 3, 4, 5, 6. Again, we might have really short, like if we did 3, the number 3 in base 10, and we converted it, we would only need 2 to the 0 and 2 to the 1. 2 to the 2 would be too big. We don't need 4. That's too big. We would need this and this. So 3 base 10 converted to base 2 is literally 1, 1. Strange thing, binary. Okay, and our last example is 47. So let's do this. 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. And I know you don't have to write them in underneath, but I swear it helps me to think things through. Otherwise, I have some bond moments. Okay, I know I need a 32. But 32 and 16 is 48, so that's too big. I don't need that guy. 32 and 8 is 40, so I'm up to 40. And now I need 4 more. That puts me at 44, 45, 46, 47. So literally 47 converted to binary is 1, 0, 1, 1, 1, 1. Okay, here's your chance. You need to do the other evens on the top part, so 2, 4, 6, and 8. You also need to work the back top 8. You want to come show me so we can compare answers to make sure you're on the right track. I'm grading these for accuracy. Okay, have a great day.